This is the last part of lesson 2. I would like you to try to find these things, press pause, and then we'll go over the solutions. First one, f of x equals 2x cubed plus 5x plus 3, and please find the derivative with respect to x of the inverse of f at -4. Pause. Okay, so here we go. We're going to utilize our formula that the derivative with respect to x of f inverse at b is 1 over f prime at a. So we know that f inverse is going to go through the point -4, comma a. The goal is to find a. F is going to go through a, comma -4. So the function's value is -4, and the input is a. And I'm going to make this equal to 0. 2a cubed plus 5a plus 7. And I'm going to find a value of a that works. Generally 1, 2, -1, -2. And if you see here, a equals -1 works through guess and check. So f is going to go through the point 1, -4. And f prime of x equals 6x squared plus 5. And so the derivative with respect to x of the inverse function at -4, that's a -4, equals 1 over f prime at -1. I think I meant to say -1 over here, which is 1 over 6 times -1 squared plus 5, and that's going to be 1 over 11. Number 2, check out the example, then press pause, see if you can solve it. Let's see. I like to do this. I like to say f inverse is going through -7a. That means f is going to go through a, comma -7. And the derivative with respect to x of f inverse at -7 equals 1 over f prime at the thing I have to find. So -7 is 5a cubed plus a minus 7. I'm going to find the 0. 5a cubed plus a plus 0. And remember, if you find a value of a, there's only one that can work because these are functions whose inverse is also function, which we can show at the end of this example to review. Anyway, I hope you see here that the value of a that works is in fact 0. Okay, we have to find f prime of x. F prime of x is 15x squared plus 1, and f prime of 0 equals 1. So 1 over 1 equals 1. So the derivative of the inverse at -7 is 1. And just to review from the last video, because the derivative, which is 15x squared plus 1, since that is always bigger than 0 for all x, we say that f is always increasing. Therefore, f is 1 to 1, and therefore the function's inverse is also a function. The formality or the format of that is in the last video. Okay, finally, let's do a look at why this formula works, that the derivative of the inverse at b is 1 over f prime at a. So I'm going to draw a generic function f of x. That's 1 to 1. So here's f of x. And that will pass through the point a, comma b. And the slope of a tangent to that, let's see if I can do it on this technology. Yes. The slope of the tangent is y minus f of a equals f prime of a x minus a. Now, if you remember from last year, that the inverse is going to be a reflection over the line y equals x. So the inverse is going to look something like this. It's not necessarily the greatest drawing, and that is going to pass through the point B comma A. If you recall, to find, this is y equals f of x, to find the function y equals f inverse of x, you have to switch the x and the y. So if I do that, to find this tangent, we want the slope of this tangent, which would give us the formula that we trying to get over here. And the slope of this tangent, I'm going to switch x and y. So x minus f of a is f prime of a, x minus a. Now I'm going to just use some algebra to solve for y, and I get the following. And I'm staring at this because I realize something's wrong. This is a y, because I had to switch the x and the y. Now it looks better. So now we get y minus a equals 1 over f prime of a, x minus b, where f of a equals b. So there it is. So that's the equation of the tangent to the inverse function at the point b comma a, and then the slope, the thing here we're trying to find, is 1 over f prime of a. A little bit tricky to do on this particular format. But there it is, and that's the end of the lesson. You may have to watch parts of it over again and get the homework assignment in class. The end.